Yeah, I won't bother with setting it up too much. That's because it's been a really short period between live streams. I'm just gonna call it the part 2, honestly. Yup. Hello everyone, welcome to the live stream. I don't know how well prepared I am. I don't think I am well prepared at all, so give me a second. Give me a second, let me just gather around everything that we need. This, that's proper, that's good. You, come here. Now what have I done? Not you or you. Hi there, Sugar Sticks, hi! Wasn't here for months and months, and welcome back then. Wait, have you changed your nickname perchance? Because Sugar Sticks. Anyone here? Not yet. Not yet. The live stream has just begun. It's just begun. Okay. Let me just unplug all my power tools. I really need to clean up my workspace. There's so much garbage everywhere. Speaking of garbage, I'm changed. I figured because I didn't remember the nickname Sugar Sticks actually. Would you mind telling me what your nickname was? Because I'm gonna wait for someone to come. Whatever. Fine. I'm gonna. There we go. Okay. Part 2. As you can probably hear, I am feeling better. Who is that? Oh, it's you, I remember. Okay, that makes sense. That makes sense. Let me just close the door. There we go. There we go. Okay. We are back. Now, what has happened in between the last live stream and this live stream? Not much. It's been like, what, an hour, 2? I don't know. I ate. That's one of the major ones. Another thing that happened, I went and I picked up the packages. That was neat. And also, oh, look at this. Oh, there's a bit of a... You can see my floor on the other side. Also, I've tried cutting out another one of the visors. It didn't work well, and I've got an idea, actually. An idea with which we will start, and that's because it's nice to have something printing in the background. Oh yeah, the thing's printed as well. These are the things that I was printing. So I'm gonna leave them for there for now, and then we're going to. Oh, I'm lonely. Sugar Sticks, trust me, I've been there. I am the one streaming. I've got an idea. When it comes to the visor, the way I want to do it is I wanted the visor to be like 2mm thick, out of plexiglass, and then plastered on top of it would be the foil. However, I just realized, why can't we just do the foil? Why can't we just do, like, why is the glass there? I do get it for structural stability and such, but the glass is making the entire process so much more tedious. What if instead, hear me out, we go in right here, and what if instead of having this be really thick and such, hold on, is the sound off? The sound off, okay. Right, we just go into the cut and we change it up so it will be a bit smaller. There was like a way to... Oh, is 1's the smallest you can go? Fine. 0.0 or 0.1, I suppose a millimeter. Well, to 1/10 of a millimeter. Yes! And then this one will be just whatever's left. Like this. And then what we can do is we can go right here and we can make this entire thing smaller again. Someone's driving it right outside my window. Shut up! I'm busy. Right here, we change it from a 3, we change it to a 1.5, for example. And that way it will be really, really thin. And it already messed up on what? Oh yeah, on the squares, that makes sense. Right, edit feature. Let's do 0.5, I imagine. We don't even need them anymore. Ah, whatever, might as well leave them. And the reason why this would be neater is because then right in here we can add in the foil, which might fall out, but hopefully won't. Oh, we could set it up in an even better way, because we can like cut holes inside the foil and we can, well, that could cause tearing. It's a bit, whatever, let's see. The point is, once again, it gives us a lot of space to play with. I'm talking myself. Well, so far, yeah, apparently. Okay, so that was the first change I wanted to do. First real quick one. Except this right now is for some reason overlapping, apparently. No, that's just a visual glitch. Okay, got it. Sick. So that's the first change to the mask. Now for the second, I wanted some kind of model to... Yeah, I remember. Okay. I remember now. I remember. So let me just first of all export these. This will be mod visor skeleton module 4.0. No, it'll be 4.2.0. 4.2.3 actually at this point. Have we reached 3? No, I think 2. There we go. We export this, and then we export the 2 little pricks. These pricks. Oh, this is gonna be... I misclicked. Ah, shit. Piss off! Piss off! Oh, you little twat. I swear. $10 more till 900, $110 more till 1000. Oh my, can't you... 1000? I can't believe this will happen even. Piss off. There we go. Cool. Export as is what I meant. Now, this one, the same idea, 4.2.2, like this. We add it in. And then there's one more model we need to make. What is that model? I am so glad no one asked. You see, if you remember from the last live stream, which you should, because it wasn't that long ago, I have, right here, a piercing, an industrial piercing. I know it's small, but you can see it. And the curious thing about it is that it's fluorescent at this point. It is actually fluorescent, because the glue worked. However, it's a bit shite. So how do we fix that? I am so glad no one asked. You see, the way we fix that is obviously by first making a mold for the piercing. And then once we have the mold, we can fill it in with the fluorescent glue we've made, which is just a mixture of glue and fluorescent. And then it's so much fun to just look at it. It's honestly, luminescence in general is beautiful. And fluorescence is just the easiest one to do. Let me just close this, I don't want to knock it over. Perfection. And so what we need to do is we need to make the mold for the piercing. What's that? 4-digit 7 segment display counter? Well, you don't need to say counter, it's just a 4-digit 7 segment display, yes. This is a bunch of random electrical stuff on my desk. It's a wacky amounts. Okay! So, that mold will be a completely unrelated project, so I'm just gonna make a new part for it. And ideally we'd like, I imagine, something like a part that we can repeat 8 times, yes, okay. So here's the idea, let me first save it in workshop, order, I don't know, piercing. And then we're gonna do mold. Beautiful, lovely, perfect, fantastic. I need to play some music for myself because I'm sitting here in complete silence and it's throwing me off. I need something playing in the background, some kind of Iron Man music, you know? Don't press Alt F4. Cheers, mate. Thanks. Thanks for letting me know. Let's do... Okay, so the piercing. I need to measure everything out and make sure that it's proper, that it's good. So the size of the diameter is 1.75, which means if we leave 2 millimeters, that should be enough. Okay, so right away, let's start making it. Front plane like this. Okay. And then what we're going to have is we're going to have it like so, actually. 1.75, that's our piercing. 1.75. There we go. Then what we do is we trim these. Like so. And then horizontal, vertical. Why are none of these vertical? Because it already is vertical. Can I move this? Oh, I can. Oh, that is not good. There we go. Fixed. Then what we would like is, I imagine, these two to be equal. And there we go. Sweet. This will be the basis of our mold. We could have it like snap together somehow if we're clever. Am I feeling clever? Not really. Although we could have like a very simple angle. Yeah. I guess. Like this. Like this. And then these two would be perpendicular. Right, and now if we trim these two, then this should all snap together quite nicely. We can make another... Okay, there's a lot of things we can actually... My goodness, 3D printing makes everything so much easier. That's because right now we can save this. Extrude boss base for... And now the height of the piercing is... Let's do 34, why not? Yeah, why not? 34. 34 seems to do the trick. Which means divide by 2, 15, 17. And then what we need is we need a sketch on top like this. That will be, and this will be the difference between these two. That's not what I meant. The difference between these two will be basically the coat. So how much of it? Hi, the stump. How you doing? So the difference between these two will be the coats. How much coat we want to add in there? I imagine 0.25. Is that good? I don't know exactly. No, with a quarter of a millimeter. We might want to leave a bit more. This is gonna be rough. Because it's so tiny. Oh, whatever. Extruded cut. And then we wanna do 16, not 17. Actually, we might, well, a millimeter already. The problem is that this part is actually so deceptively small. You have no idea how tiny this is. It looks much bigger than this because you have no reference, but this entire thing will just house the piercing. That is tiny. So here's basically what we'll want. Mold. Like this. And then we're gonna have 1, 2, 3, 4. Maybe we don't need to print 8 of them. Maybe just 4 would be fine. If we go in, if we select everything, and if we mirror it along this plane. Then we go to the assembly. Right, and so the basic idea would be that this to this face made this to this, this to this, flip. That's already very difficult to figure out. Right, this to this. Okay. It's proper, then think this to this one, right? I think so. Yeah, that looks right. Okay. And then finally this one to this one. Back to back. There we go. And so this is basically how our mold will look. Inside, we're gonna put the piercing with the ball sticking out. Get your mind together. And then this, we're gonna fill it in with the fluorescent glue. Fluorescent glue is going to stay there, solidify, and then hopefully afterwards, because we have 4 of them, it should be easier for me to just take them off. Because the glue, we have to remember, it will stick to the piercing as well as the plastic. And it's honestly a bit naive to think that will stick to the metal better than the plastic. But the whole point will be that hopefully we'll be able to, you know, break away the mold and not too much will get off the piercing. That's a bit idiotic. I mean, it is. Also, it's not gonna solidify all that well. Like, this isn't fine coating wise, but we might need some fine tuning. So one more thing I would like to do is take the smart dimensions of this to this. Oh mate, that is absolutely not what I meant. This face to this face, 6 millimeters. Or did I really not set them? I might have not. Yeah, I didn't. Okay. This... Let's do it as 3. Are you gonna break everything? I really appreciate if you didn't. Would you mind not breaking absolutely everything? Looks like a tight fit. Okay. Splendid! Which means now we have the whole thing of the size 6, which means we can make a new part, and that will be the mold holder. Boulder. Okay. Which is simple as it gets. We just assign the middle. So, vertically aligned. We align the middle horizontally aligned. Then we delete the outer one. Actually, what am I doing? Like this. Then we set these to be equal. Then we set this one to be 6 millimeters. And then we select them all and we do offset entities by, I don't know, 2 millimeters, fine, whatever. Mold holder. This seems fine. And then we go back to the full mold, then we can add in the mold holder, like so. Perfect. There we have it. This will be our mold. Why is everyone so quiet? Come on. I'm feeling that mad scientist just rushing through me. And you're all just sitting there quiet, not allowing me to release my creative wonder. You're making me feel crazy. Okay, then what we do is we just print them all, I suppose. And by print them all, I mean not only this, but also the mask. So, what is it that we need to print? Great question. We need to print... the mellow, in the billows, even over the sun, yeah. You understand, mechanical pains are the rule of everything. There we go. Auto on the floor. It should be trivially quick. 40 minutes. Okay, that's not trivially quick. I don't know. Maybe it's more material than I realize. 2 of these. It's consequential enough to slip you into a trance. And then what we need to do is we need to export this one. Centric, ha 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 ha. Into the wall of mirror clear, I'm standing so tall. And then the other one. This one. I hope this will print correctly, because to be fair, I haven't really added any tolerance, have I? The reason why is because it's meant to be a mold, but at the same time, my 3D printer doesn't have infinite precision, does it? Okay, we do need 2 of these. And 2 of these. Well, 4. 2. 4. How much? 40 minutes. Not bad. Alright. Do we have anything else to print in the meantime? I don't think so. So we're gonna let this print. And we'll check back on it in an hour. And then hopefully we'll be able to code the piercing correctly. Isn't that something that only I am excited for? Anyway. In the meantime, we're gonna do something different. Obviously. How about a bit of an opening? Huh? Cheers, Jesse. I appreciate it. Anyone here excited about a bit of My goodness, why is everyone so quiet? What's up with y'all? Is it because I'm streaming at 2 PM in the middle of a work week? Nah, that can't be it. Okay, so basically, I got some packages. I thought we could open them. So let's do it. Oh, what is it? Why is this empty? Why are you empty? On the hollow, not empty. Sorry. There we go. Get off. What are you? I don't remember what I've ordered. Oh, my electrical there are so many electrical components over there. Oh, gee whiz. Hold on. I need to move this out of the way somehow. Okay, there we go. We've got so many things. Okay. 2 different speakers for the mask, believe it or not, because I don't know, I wanna add stuff. Then we have oh, this is genuinely useful actually. I just got a lighter. The problem is that my current lighter I've been using ran out of the thing, and I'm hoping that if this lighter, so I just bought an electric lighter, and that's because it's not gonna run out of fluid. Can I set ethanol on fire with this? We're gonna find out in a second, because that's actually the main reason why I bought it. A couple rolls of insulating tape, which are just going into my storage container. Obviously, insulating tape is always useful. Then a laser. Right, that's just a piece of paper. A point laser this time, not a line laser. I don't know why I got a line laser last time. And then these. These are fun. Do you know what they are? I'm just kidding, obviously you don't. How would you? They're integrated circuits. They could be literally anything. That's because, first of all, I got an audio amplifier for the speakers, obviously. Multiplexes, at least I do believe that they are multiplexes, or the bit shift register things. The point is, we can get a lot of pins out of little pins with these, which is convenient. Then I also got, I think this is another microphone. I haven't, why do I have so many? Alright, doesn't matter, it's something, the point is. And then, remember how last stream I looked up something? Well, these are them. These are these. Dems. It's this. Hold on. It's this. It's dems. These are the LEDs. RGB LEDs that you can use in order to light things up. And so hopefully, on today's stream, we'll try to design a PCB for them. Another buzzer. Why do I need so many things? I always buy things because, you know, when you're already buying them, then it's much cheaper to get them in the same package. And so I end up with just all of this stuff. I mean, the speakers are nice. I imagine they would just be nice for the mask too, other than that. Don't matter. The main, oh, that's also going into my drawer. The main prize, piece de resistance, are these for now. So, we need to pick one of them and we need to do the thing. Right here. We have 6 loop. Oh, yeah, you can't see shit. Once again, why is no one talking? You're all making me feel crazy! Okay, we got 6 loop pads. I know you can't see it probably because it's really tiny. But 6 pads. And 2 of them are ground, 2 of them are voltage, I'm guessing. Then on one side we have the data input, on the other side we have data output. And we did find the datasheet which describes exactly how they're supposed to play together. The only downside I would say we have in this case is the fact that soldering this to anything would be an absolute bitch. But hey, we live for the challenges, don't we? I feel like beforehand we should test the lighter. Absolutely love this thing. The electric lighters are great. I do adore them. And just. But let's see if it passes the test. The only test that's important to me, which is, can it set ethanol on fire? That's all that matters in my life. 90% of things I do are just setting ethanol on fire. So, oh, that's a lot. That's a lot more than I should. Okay, let's get rid of the rubbery parts because they can actually, you know, stink up everything. Put them to the side. Yeah. You're beautiful. This might be one of the best gadgets I've bought, because considering how often, it's nice and warm as well, considering how often I set things on fire, and how annoying it is to get lighter fluid, this is just great. I'm gonna keep it in my lap pocket. Just useful to have it there. Oh no! There's a bunch of fluorescent material in here as well! Oh, shucks. I kind of forgot about that. It is absolutely flammable, because the solvent I use is ethanol. It's comically fluorescent, in fact. This patch right here looks more fluorescent than... I would say it's ever slightly more fluorescent. Yeah, you can see on this side, it's burned away fluorescence. That's what can happen with too much heat. The carbon dots just get all screwed up. So you need to be careful. That's why we can't actually make them by dissolving urea and citric acid and ethanol, just burning the ethanol away. As nice as that would be, can you imagine if that actually worked? It would be beautiful. Oh yeah, I have another package. I don't know what's in it. I'm guessing the electric heater, which I will need for another project. Long story, you'll see. Ah. Come on. Let me just check some real quick. Okay, there we go. Had to test something real quick. I can't watch a 2 PM stream, yeah. That's on me, to be fair, for starting a stream and this awkward over timing. But to be fair. Okay. Come on. Ah! Get off. There we go. Space off this way. Let me see. What is you? Yeah, it's what I guessed. That's an electric heater I got. Trust me, I have a reason. It's a it's a very naked reason for why I have this, but I have a reason. I kind of want to test it. I kind of really want to test it. How would I test it easily? I can test it by getting myself the cables. Right. Like one of them into this, plug the other one into this. That's a bit of a pickle. 200, if this is actually 250 volts, that's gonna be quite a significant problem for me. It's AC. Yeah, I feel like it might be. Shit. I quite severely fucked myself up then. Because I would need a transformer, and I don't feel like stealing another one. I mean, it's a proper good heater. I just need a transformer then. It's always something in it. It's absolutely always something. Alright, whatever. You're going to the drawer again. Another one. Okay. Okay. It's time to do the thing. Oh, it's gonna suck. Okay. Soldering it onto the finer board as well is gonna be a massive pain. Because it's the pads. I'm gonna have to ask Tefta how he did it. Yeah. Unless I buy the components themselves. Yeah, I suppose I am being a bit of an idiot in this case. Because I bought these with like tiny PCB boards. Let me just... Oh, that is really far on my desk. I'm gonna have to reach a fair bit. There we go. You can see they have like 6 pads under them. When I move it around, you can see it best. That's the actual connective material. Let me just go around and move the camera so that you can see it much better when I do my thing. I was screwing it on the wrong way. There we have it. There we have it. So now it's all focused and well. Let's have this. And let's try doing the thing. So, in order to make this usable, we need to solidly deposit something. I still do have the, what's it called? You know, the little PCB boards that basically help you go from the SMD standards to the pin standards. However, I'm not gonna use one of them on this. That's because right here, I feel like it would be much easier for me to just solder a typical wire. Like this. Now that's not easy. Easier. I really need to zoom in like crazy in order for this to work. Okay. It's gonna suck. Okay. Okay. All right. It's about as thick as this blade. Which is to say, not very. Which makes handling it a tad difficult. You know what I could use? I'm an idiot. I have it on my balcony. And the problem is that they're a bit dirty, mainly because of how I've used them for. That is, I've used them. Oh yeah, make it. What should you do with water? You're dealing with electronics. What could possibly go wrong? What a genius idea you've had. I'm fine. Just need to clean them off. Okay. There we go. Shit. Hi, the farmer main. Hi and welcome. That's proper. It melted a bit of the rubber onto my pincers, but it appears to be properly. What does that mean? YouTube is giving experience to people who chat, but it only works for a single live stream, so it's. I don't know the reasoning much. Okay. So that was the ground. Then I'm just gonna use whatever wires I have. Live stream roguelike. Yeah. You can level up your stats that way. Poison resistance useful with these streams. Wish I had access to that. This looks good. Now all we need to do is just get a little bit of this and repeat the process. Looks like Butcher's nails. Implanted in Remco to have Dutch Angren. Okay. Why would that look like Butcher's nails? That looks nothing like Butcher's nails. Don't Butcher's nails look like tubes? Okay. So this should be the voltage and ground. Ah, fuck off! Get back in there. Not done with you. There we go. I literally have an I can fix him feelings about it. Okay. Oh, the entire chip got a bit hot. That worries me a bit. That could spell out bad news. Also, that was kind of the easy mode. That was kind of the easy mode. Yeah. That's because we soldered the two things. Why am I not recording this? I need this for a video. That was the ground and power. Now it's time for the actual problem. Which is the DIN, mostly. The output, I can live without for now. Remgron! Oh, you just made me inhale a big puff of lead smoke. Oh, Rengron. No. Oh, the Remgron that's very funny. The lead smoke, yeah. the soldering smoke. You know how this is smoking? But shut the door. I don't think these wires are suited to soldering. They just don't stick. I am incredible. We saw a tin in school. Well, I can tell you that on my soldering thing, it says SN60, SN60 PB40. And last time I checked, PB was in fact lead. Unless I'm wrong, let's see. Is PB lead? Yep. Yeah, it's lead. Okay, well, yeah, I'm soldering of lead. 40%! It's not bad, could be worse. Okay, there we have it. Now it's time. It's so tiny. Like, my goodness. Now it's time to try to control it. So, we have this. Our Raspberry Pi Pico. Obviously. Then, what we're gonna do is we're gonna open up our thing. I don't know where to put it actually. Behind me. There we go. Yeah, Outlook seems to work tremendously. Beautiful. So what we're going to do is we're gonna first plug in the ground to ground, let me be optimistic and turn the soldering iron off. Ground will be orange, power will be yellow. Shit! That's what I get for being optimistic. I could just cut these wires up actually. You know, because these don't solder, they just fall left. Oh, this one did. This one got soldered right up. Why didn't the others stick? Whatever. Okay. I'm just gonna... This one's the ground and we're going to do this. There we go. We need to solder these right here. There we go. Perfect. Yellow into ground, orange into power. 5 volts. Ah, does the Raspberry Pi have 5 volts? That would be the USB connection, wouldn't it? Raspberry. It wouldn't be the VSys only, it would be the... That's 3v3 out. Oh, it might be the V-Bus, I think. I think it might be. Why can't you just fucking stick? Why you like this? Stay. I didn't turn off the soldering iron this time, I was not feeling optimistic. Oh, I fucked up. Oh, I fucked up so badly. Get off, get off. I am not having fun with this. Fucking stick, mate. Okay. Lowest ground. Power. There we go. Now what we need is we need the input. Which fucking isn't solid. I'm fine. I am okay. How we're gonna do the inputs is beyond me. I'm just gonna prepare the cable regardless and hope that it's gonna all work out well. I'm going to place this right here so they won't move too much. Okay. There we go. This looks perfect. Lean to your mic and speak a very low, Polish flavored voice. Doing this, don't tell me what to do. Come on. I just got a bunch of solder in my hand. Ah, that stinks. Ah, that stinks real bad. Okay. I am soldering it backwards. I know, but I don't have an... I just shorted it. Because I have plugged into the Raspberry already. I'm such an idiot. Stay. Don't fucking short again. Stay. Bad. Bad boy. You are a twat is what you are, not even a bad boy. I've been in the morning. I am much better, Adrian. I did get the LEDs. I'm gonna... I think I've ruined this one. Well, that's why we got spares. Fucking hell. Okay. Yeah, let's try it again. I'm having so much fun. Okay. So what we need is we need... we need to solder it. That's what we need. How are we going to solder it? Well, I was still making on the homemade custom PCB. A different one, but yes, yeah. Why are you putting it in quotes by homemade custom PCB? It's just like a custom PCB. I suppose I'm making it at home. That's mainly because my office is my home. This day of my midterm, I'm really nervous, but my anxiety doesn't care. Well, as I mentioned, I have been told on multiple occasions that I am great at being a distraction. Absolutely phenomenal. Okay. Come on, buddy. You can do it. I can hold it with this, with the pincers. Like this. And then it's just like soldered in. What I should do, however, is hear me out. You should solder your finger to a button. Here's what I should do. I have an idea. We can put the solder material on it first in like tiny little blobs. Like this, like this. There we go. We've put a little piece of solder. Now we can just clean off the thing. And then let's try to solder these little wires to it. Fucking hell, that's so much easier. My goodness, that was so much easier. Okay. There we go. It is really hot, but at the same time, it is already soldered, so that's good. Like this. And now what we need to do is just solder one last pin. One last, that's it. So it's wasted Wednesday time. Obviously it is. Can't you see us what I'm doing? I'm inventing. No, I'm just kidding. I'm gonna get drunk after the last stream. And then I'm gonna invent something. We'll see how it goes. One more wire. Actually, oh, maybe I shouldn't go with wire. I should probably just go with... There we go. I do have to say, there's one thing I really want to make. Come on. Cut this off. There we go. Now the solder is already there, so... should be trivial, right? The annoying thing is I need to hold it left-handed. Because I only have one right hand, actually. Yeah, it's a real pain in the ass. How did it work on the first try? I will not know. but I'm just glad to be involved. Splendid! Triple pins, simple as it could be. Can even put it on its back now. Perfect. You should make a program which connects your coffee machine and pours you a beverage of your choice on command. That's not as easy as it sounds, and not for reasons you would think. The only difficulty is the piping. Funny enough, it would be easier, I imagine, to build that kind of machine than to amend the coffee machine into it. Okay. Plug in this. Orange will be our data. Then blue will be ground. And green will be... Oh, if only these pins fucking... What am I doing? Where's my breadboard? There it is. There we go. Ooh, I don't like the way it's bent all of a sudden, but... Well, if it works so far, I'll take it. Oh my goodness, these pins are tilted. So I need to bend them back into shape. It's really annoying. Okay. There we go. So, power, we're going to go with this one. Nope, that's round. Get your ass out there. Oh, you fucking... Stop being a cock and get in there. Okay. These wires are really bending every single way to avoid just going in. There we go. Okay, let's test it real quick. Where's my diode? There it is. This should shine. Perfect. Yeah, that's what was supposed to happen. Perfect. Great. Sweet. Nice. Neat. Lovely. Now, hide the cape. The mask is gonna be lit when done. I don't know if that was meant to be a pun, but if it was, then very good. Come on. The only problem is... Oh, I just realized this is in the way. There we go. Now we can see it a bit better. Come on. Get in. I cannot connect it to the first pin because it's... Fucking hell. It's fine. It's fine. We can cheese this, which is always a great idea. Perfect. Now, to the coding station. Ha ha ha. Basically, this is what we're looking for. And first 24 bits is what we want to send. Which means we want to set, for now, let's try white. Which, if I'm not mistaken, glowy D. Okay, it's like LED, but just shut up. Glowy. Okay. Just LED. Whatever. RGB LED. This is gonna be the whatever, it doesn't matter. The point is, what we do is we do right here. This is our 0, this is our 1, which means where's the table with the specific timings? Right here. MicroPython wait for microseconds. Is it like a microsecond version of sleep? That's really slow for some reason. I'm sorry, why are you running so slowly? Huh. I'm sorry. I might need to go and Google it instead. Oh, that's awful. I need to use Google. No, we're looking for sleep seconds. Sleep milliseconds. Ah, we need microseconds. There we go. Sleep. Okay, so import time. And then send RGB. Sorry, def send RGB byte. We will take a RGB. Okay. Like this. And then what we will do is right here we have microseconds, and it is gonna be quick because T0H send 0 is going to be time sleep US. Yeah, so it's first high then low, which means send 0. Actually send bits and then bits. If 0, then we'll have this. And then how many microseconds in each? Well, we do a 1 on the 0 for 0.4 microseconds, and then we do it for 0.85. That's our B0. Free print is in the background, but the sound of the free printer is printing. ABS definitely has some extra commands for the mask. FGC9, what is that? FGC9. What is FGC9? Cool. Okay, if this is a 1, then what we do is we do 0.8 and 45. Like this. And that should allow us to send bits. So now what we do is, in order well, actually, toggle file system. Oh. Oh, cheers, Jesse! Speaking of, what happened to my file system? Never. I'm sorry, what happened to my Pico connection? There. Splendid. RGB LEDs. RGB LED.py, and we're going to add it in there because import from machine import page. And then import RGB LED. Then send bit. Actually, no. Pin or LED pin is equal to pin 0 pin out, and then send bit. That's annoying because we don't need send bit. Do we make it, you fucking idiot? Def send a byte number. Actually, pin and number, and then for I in range 8, Python bitwise operations. DuckDuckGo is just dying today, so I need to use. Okay, so then what we do is we do send bit pin and then number, bit shift to the left. I guess if we do the white, it won't matter, so we can do whatever now. So I undid the 1. Like this. And then def send color is going to be pin and color or RGB, and then we're gonna have send byte. The reason why is because all this has to happen quickly. Let's see if my implementation works. I am just simply thrilled to find out. Let's reset. Def, no, send color, led pin. Isn't defined. What did you import then? Alright, whatever. Send color. Can't convert float to int. What is wrong with me? 7. Right here. In microseconds I needed to be, oh, you are joshing me. Oh, you are joshing me. Positive was you, oh no. Oh, no. Oh, I'm fucked. Hi, the Tefta. Whoops, I should watch my language. I am. Oh yeah, no, I am done. There is. Okay, Raspberry Pi Pico C SDK time delays. How specific can you get in C? Oh no. And the freaking DuckDuckGo is failing me again. Can you do nanosecond delays? I am not gonna have fun, am I? The good thing about this is that this will be a trivially simple thing to implement in C. I'm sorry, how do you time delay Raspberry Pico time delays? I refuse to believe that time delays are such a... Oh, DuckDuckGo. Hardware API. Oh, I should just read documentation. What am I doing? Yeah. Pico C SDK, yeah, 100 clocks. Right. Did I turn off? Oh, I need to turn on something on as well. It's just sitting there for no reason. Okay, example, yes. I should check what's the... No, it has to be, like... Yeah, once again, look double. Yeah, okay. Pico to documentation. Yeah. Pico 2. I'm looking for the frequency. Or the clock, I'm an idiot. Yeah. Right. What we're looking for is... What I'm looking for doesn't appear to be easily accessible, which worries me. Can I just control the clock? Internal oscillator. Yeah, what frequency is it? Why do you need so short of delay? Well, it's because this thing right here, this, is an LED, an RGB LED, and I need, where is it? There it is. I need from 0.4 to 0.8 microseconds for it to register. Which, a NeoPixel library. What is a NeoPixel library? Is there no way to do delay in nanoseconds in MicroPython? Or is it that Raspberry can't handle it? Individual RGB LEDs in series. Just one wire for all of them. I mean, my problem isn't that I don't know how to code it, because, like, this is the entire code, that's it. Nothing else needed. My problem is that I don't know if Pico is fast enough. How many hertz do we need? Kilohertz, that's a millisecond. Megahertz, that's a microsecond. Yeah, tens of megahertz should be fine. So all I need is just figure out a way to Raspberry Pi Pico wait for nanoseconds. That's what we need. Experiencing an outage. Okay, nanosecond delay, yeah. $400 nanoseconds, that's exactly how long I need to hold mine. Convenient. It's just assembly for the time. Let me see if someone finished though, maybe. The small delay, calculate how many ticks you need and subtract from... Oh, Okay. Eight nanoseconds per cycle resolution, though in reality there is some overhead. Is there no other way to access the clock? Nanosecond timer. Oh, Stack Overflow, yes, please. Please. Nanosecond timer. At best microseconds, okay. Okay, what if we switch to C, however? Would not going to be accurate enough to get nanosecond precision. Okay, what about hundreds of nanoseconds? I don't need single nanosecond. I need like fractions of microsecond. Pick a compiled language. I know I have to pick one. Just tell me where do I go from there? I know. We need the documentation. I keep looking at this. Wait, it's obviously not gonna work. Okay, there we go. Yes. Documentation. Pico C is decay. Hardware. Yeah. Is there anything that would be easier? No, I don't imagine. Okay. It's gonna be fun. Very close to trader performance. The multiple clock generate provides the required clocks. The architecture allows you flexibility on 2040. That's not even my thing, is it? Okay, we have this. So hardware clocks, you include that. And then you do clock configure. Why don't you just sample the clock and do the XYZ when enough time has lapsed? What do you mean? Okay, this seems good, I would say. Oh, this is for... yeah, okay. How they specify that RP2040 has clock number RP2040, whilst 2350 has 2350. Instead of time sleep, just look at the clock ticker and then do enough tick, and then if enough ticks have passed, do XYZ. I suppose that could work. Yeah, I suppose. I'm still worried the MicroPython might be a bit too slow for this. Because like, this is basically one order of magnitude away from the base clock. And that worries me a bit. Why do I keep trying the same thing over and over again, expecting shit to change? What is the definition of insanity, by the way, unrelated? I'd see software SPI, do this to a microphone, so it should be doable. Yeah, but wait, software I2C? I was about to complain that hardware I2C has hardware implemented, never mind. Software I2C really can do it. That's impressive. Okay. Elapsed clock time between 2 points. Okay, what I need is I need like the processor time. Time-related functions, and I need something... Wait, wouldn't that be the ticks one? Am I not an idiot? ticks. Return increasing millisecond counter of an arbitrary reference point that wraps around after some value. It's not explicitly exposed, but we will refer to it as ticks max in further discussion. Okay, that makes sense. So the ticks, we can check the ticks and repeat over and over reading the ticks over and over and over again until we get the thing. Hold on. And just proper CPU ticks. They do have proper CPU ticks. Examples. I really wouldn't. So this is how you do it. Right? Hold on, let me copy it. Which means right here, instead of time sleep. So like, if I do proper sleep, just the calling of the function will screw me up on it. Okay. Okay, we have deadline. Milliseconds, no. Absolutely not, not even close. CPU. However, what is the CPU? What am I doing? Import time, print time, ticks, CPU. Module has. Oh, I'm an idiot. I'm an idiot. Okay, there we go. That makes sense then. Alright. Now, a bit of mathematics could work, although I am worried that it shouldn't. That's not how I should do it. I could, like, this will be so much effort, but I could pull it off. If I calibrate it, so if I figure out how many CPU ticks we have in a microsecond tick, then that will tell us the length of a CPU tick. And once I have this length, I can figure out like the closest approximation of what a 100 nanoseconds would be. And 100 nanoseconds is all we need because the precision is 150. Which means that, yeah, this should work then. Okay, take CPU 200 and then check the difference between the two. If the difference is greater than 0, a little of something, I don't know, just A is equal to, oh no, what it would be like the smallest, I imagine A++, but then you need it, oh you can't do that in Python, right, A plus equals 1, and then just, well, loading in the value will give us a hell of an error. I really like it. I do have to say though, I'm having a lot of fun. I'm doing it in a way that's completely unnecessary, but I am having a lot of fun while doing it. Let me just make this bigger, by the way, because this is the main meat and potatoes at the moment. Okay. So what should we do first? Because the CPU ticks, that's not in seconds, is it? That is in the unit of time being CPU tick. It's not actually a unit of time, it's more like a unit of... It's not really a unit of time, it's more like a... Well, it is a unit of time, there's just relative time. Time ticks microseconds. Yeah, but time ticks microseconds is too slow, as I mentioned, I need nanoseconds. Yeah, I guess that's what we need to do. I guess we just need to calibrate. We just need to calibrate it. So, For here's what we're gonna do. We're gonna set beginning to be equal to time ticks CPU. It feels wild to put something this low level, but whatever. Times, because every single line is gonna add to it, but it's fine. Take CPU, and then what we also need is beginning of microseconds, which is equal to time ticks microseconds. Now this is a problem because there's already gonna be some kind of discrepancy between the two, but I'm just gonna close my eyes and pretend it's not there, because otherwise I don't know what to do. So this is what we'll have. Then afterwards we're gonna do while time ticks microseconds is equal to begin this. We just need to pass the time somehow with something that will technically take time, but can I in C I could just do this. There we go. That's what I could do in C. I could just leave a number there. Can I do that in Python? Because I would ideally do nothing in the middle. Just let the loop continuously check if it did the thing yet. And then once it's done, then 1 is equal to 1. You can do 1 is equal to 1? Oh, that's lovely. There we go. And then afterwards, we'd end is equal to time.ticks CPU. And then pass. Genius, thank you. And then difference is equal to end minus the beginning. And so this is roughly, very, very roughly, because also, in order to calibrate it even better, we should wait, actually, until the microseconds switch. I was gonna beg you is equal to this. Because we could start the code like halfway through a microsecond, right? And then once we're done, we just get half a microsecond. Which means what we need to do is we need to do it twice. We wait for it to roll over. There's probably some more clever way to do it, but whatever. We wait for it to roll over, and then once it's rolled over, we run the code. In which we do this, and then we get really well calibrated. Well, really is an overstatement. We get a calibrated timing. Now what do we do with this timing? Well, this tells us how many clock, like CPU ticks we have in the microtick. Then what we need is we need to, for 85% of the time, okay, so right here we have, let's call it calibration or whatever. It's the conversion rate, right? CPU ticks microseconds. So we need oh, my camera just stopped recording and died. That's fun. That makes sense actually, I suppose. I'm just gonna turn it off for now because we're still doing the code. No point in adding an intrusion battery just for it to sit idly and do nothing. Okay. Deadline is going to be tick CPU added cali times our number, which in this case will be 0.4 if my memory does me well. Math floor. I hope. Oh, I should just like. I keep thinking about it because, like this, there's gonna be a time delay between everything. So we need D0 and then D1. This is a pain. We have, to be fair, we have 150 nanometers to spare. And did I just say nanometers? No, seconds. To spare, which is a lot. then 85, and then this will be D0, and this will be D1. Right, and so this should give us then 0, 8, 0, 45. It's gonna be a bit of a delay between them. Hopefully it's gonna be just less than 150 nanoseconds. And I'm honestly at this point just fingers crossed and hope that it works, right? Because how else? Let's just run it real quick to see if it errors. Of course it does. Tix add isn't defined. Well, that's annoying. Because time dot, right. From time import tix add and tix diff. Okay, so I know you didn't see it because I turned off the camera. Well, the camera turned itself off. It didn't work. The question remains, which one of the 70,000 reasons for why it wouldn't work happened? Let's start the simple ones. Hold on, okay, egg on my face for turning off the camera. Now, we do have a bit of a problem, just a bit, and that is the fact that right here, you can see, it is in fact glowing. We do have a bit of a problem, however, and that problem is that you might be wondering why it's green. Well, it's because it's completely undefined behavior. Yeah, if I keep running it, eventually it's gonna change color. So that means that the fact that it just it even turned on, that is incredible for me. Oh, that's good. That's really good. Are you hot? Not even. My goodness, that's a proper good LED. That's really proper good. Okay, well, we did that, so I guess now would be time. So we done this, which means now we can use the what was it, NeoPixel? MicroPython NeoPixel. There we go. There we go. Yeah, that's fine. So now we got this out of the way. We can try the normal people way. Oh, my lungs can't take working in this office no more. Too bad for them. Okay, so NeoPixel is equal to NeoPixel. Hi, Weston Smith. Hi and welcome. And 0 and then pixel 0. NP0 is equal to 255. 255. You see, use the NeoPixel library. No, actually, I mean, wait, were we not here for the... No, this actually worked. This color I achieved using my bullshit, which is incredible. I can even change it if I keep running it. The only problem is that it only works due to undefined behavior. But I am satisfied with myself. I am proud of myself for actually implementing it. So I am now willing to do it like a normal person. Byte array index out of range. I'm sorry, why? 8 pixels. Oh, because of the amount of pixels. 1. Okay, now how do I apply it? Oh, NP right. Oh, beautiful. Absolutely. Why is that 000? That's not a black light. I'm sorry. What happens if I do 111? Or is it always the same brightness? No, it's not. Why is 000? Nah, whatever. I do kind of like this as a. Well, I mean, no, we do need 000. What am I talking about? Unless there is a separate thing for turning it off. There might be. Do I just set up the NeoPixel with a 0? No. How do I set it to be black? Well, I can do it actually by just running resets, right? I think. This is a bit of knowledge from my... Yeah, reset is just a 0. If I run reset with not following it up with anything, then am I gonna fry it or am I gonna just turn it off? How many pins isn't defined? Am I going crazy? It's struggling a bit. 0 pin out value. Oh, because it was pin out and not... Yeah, I'm an idiot. Well, it didn't work. Which kind of sucks because that means that this is the dimmest it's gonna get, which is still glowing. It's not too bright, so it's not too terrible, but it's glowing. Unless we could also turn off the power supply. It's also not bad. We could have like a switch for a power supply using the mod driver. So for over 40 minutes in office. I'm glad you got an up. Okay, so now we got this is phenomenal, by the way. This is great. This is really, really great because you see, we've got the component which we can now buy in bulk, which I'm gonna, and that means we can design the proper PCB for it. We've done electronics. 000 still off. No, my other code is not running. 000 does appear to just... Yeah, 000 juices it up. What happens if I do 255, 255, 255? We already tried it, right? It's the same, right? Yeah, it's the same. Tefta, you might be correct, but then why would that be running? Why would that be running? We did the reset. Not a boot file. Something because it's odd. Yeah, when I do 000, it does go to a garbage value. Yeah, I did the reset again. You know what I think is happening? We are getting certain noise from somewhere. Let me guess. Well, that's even more noise. Like, if I keep trying, eventually it's gonna turn off. I just need to keep trying until... Oh, damn it, I missed it. Where's the noise coming from? Because that's definitely what's happening, right? The noise. That would make perfect sense. I don't have an oscilloscope because, well, we struggle here at Make It Industries. Just unplug it. I mean, I know, but... There we go. I think it might have been the USB. Yeah, because now that I moved it away, the noise is way more consistent. Yeah, it's the USB. Well, or at least I was guessing. Oh, my eyes hurt. That's why you add capacitors to your PCB design. That is really true. Hey, I don't know. I wouldn't know. I've never made a PCB. Actually, no. Wait, no, that's incorrect. I did make a PCB once. But today is the day we do it again. That's because it works. The component works. Who would have thought? The people who designed it didn't lie. That usually tends to happen. Usually people who design stuff don't lie and tell you how it works. But still, always nice to double check. Which is convenient because that means right now we're going to do the fun thing. Yippee, it works. Exactly. What did you do in your apartment that your lungs and eyes hurt? What did I do? Yeah, I have no idea, Adrian. It could be the sulfuric acid, the formic acid, the soldering acid, the soldering material, the metal, the dissolved plastic, the flags I just released everywhere by heating up extremely, the carbon dioxide. I don't think they should be that dangerous. I feel like this things that are dissolved in it would be way more. I have no idea what could be hurting my lungs, honestly. I'm just crazy. Anyway, so, right, the thing, the stuff. So, let me just say 72 more times. It's time to do the thing. Tefta, how convenient you're here. For those who already forgot what we're doing, new project, right. We want project in circuits and then lights. For those who already forgot what we were doing, I don't blame you because I did mention it like once this entire live stream. It's a pretty long stream already. 2 hours. Time does fly by, we're having fun. Lights. Here's what we will do. We will... Let me open up so it works. There we go. What I want to do is right here at the front. That's the reason why we made the entire visor holder thinner. It's because that right here on the front we will add a strip of lights, like a very slim PCB of these specific RGB LEDs. And then what we would like to happen is we would like to set it up in some kind of way so this will function as our debug, which means depending on what happens with the mask itself, that can flash as a different color. I think it's a very cool feature, and as such we definitely need to do it. Now, in the documentation, there was a recommended setup, wasn't there? Data sheet, I know I'm calling it documentation. There we go. All of them connected to 5 volts through a capacitor to the ground. What kind of capacitor? Good question. I think I have a bunch of like one-directional ones. I think bi-directional ones here are recommended for a reason. I don't know. Tefta, what kind of capacitors do you use in your designs? Also, funny enough, that's used for ground. The capacitor is connected to ground, but not connected to... No, wait, not the ground, the power. This doesn't also make sense. Data apparently is just being sent over. Yeah, I don't think I have any bi-directional capacitor. Wait, no, I might have some. I usually use SMD capacitors 2.2 microfarads and 100 microfarads for decoupling capacitors. I don't know if I'm... Should I use SMD? I don't like soldering SMD. I have a heat gun that would help with soldering SMD. But I don't have the fancy plate you have. I don't even know if I have any, like, bi-directional. SMD is annoying unless you have the equipment, yeah. I imagine the heat gun would help a little bit, but... What I do remember, on the opposite side of my desk, I've never used capacitors. No reasonable adult ever uses capacitors unless they're designing PCBs. I have bidirectional ones. I mean, not bidirectional, only one directional. But I don't know if these work properly for this sort of thing. I don't know if this would work. We do need the other one, don't we? Let me find it. Ceramic ones. Yeah, exactly, because those are different. I'm going with DuckDuckGo again because yeah, of course. No, it just doesn't work. Okay. Yeah, I need these. What am I doing? There we go. I need these, and I have these. Which is the problem. This is the problem indeed. But oh well, we'll cross that bridge when we get... I can just order some more. I love retail therapy. I'm just gonna buy a bunch of ceramic capacitors. Oh, goodness me, I'm gonna order more electronics. How fun is that? My lungs. Okay. So, let's just take a brief look into the symbols. I don't know where the... like... how many symbols are added into the KiCad default library. Like, for example, if I look up WS2812, that's there! Why is that there but the TM isn't? Yeah, whatever. This one, right here. And it has a footprint aside. That's so convenient. There we go. How many of them will we have? Okay. Tefta, give me a random number between 6 and 12. 6.138, of course he did that. Alright, fine, we'll be going for 12 then. I don't really need them to be in line. Yeah, I mean, it's just the schematic design, it doesn't matter. Especially since the in is on the left and the out is on the right. I should have them in... I'm an idiot. I should have them like this, so I can connect them right away. There we go. That's 16. I shouldn't go 16, I should go 12. I don't even need to go 12, but I'm going 12, whatever. Okay, perfect. Now into the DIN we'll have the pin, and into the VDD we'll have the G... I can't find the rhyme, I'm not making the hat. Luckily Bandit doesn't exist in YouTube chat. For now. Don't tempt me. Okay, so the recommended setup is a VDD. Every single one of them is connected to the 5 volt and then through a capacitor to the ground. Okay, that's the recommendation. Make it should add it. GND and GND, that's the VSS. And on the other side we have new symbol to be click over a sheet. Am I not clicking over a sheet? Oh, because it's the wrong thing, right? It's this. Be so 5 volts like this. Then this is actually a very lovely introduction to PCB design, I just realized. On pure accident. That's not the reason why I'm adding this. But this is like such a trivially simple thing to design with such a convenient documentation. It is really a beautiful introduction to PCB design for me. Then capacitor. So I'm imagining it'll be C. Oh, that's it, just C. Wow, I am so smart and clever. There we go, and then this one will go into the data. Perfect. Perfect, I'd say. Yeah, that's kind of it, honestly. Like the power management will be external. We're gonna make a power managing circuit later on, don't worry. But that is gonna be external for now. The data will just be a single pin going to the Raspberry. What's that? Is it? Save. It really is a perfect introduction. I genuinely didn't plan this. Load in. No footprint assigned. Of course you have no footprint assigned, because why would you? Now, where did you assign footprints? I already forgot. Wasn't this, was it? There's like a list of create footprint, new footprints. Oh no, it was in the schematic. Right. This color changes, yeah. It was in the schematic. Right here. Capacitors are in the other editor for the circuit. What do you mean? Wait, no, that looks different. Edit symbol fields? Edit symbol fields, perfect. So footprint, and then we need to find, can I just look up capacitors and see what, not SMD, THD, yeah. I don't think, end the sentence there, but at the same time also, I don't think the footprint for a capacitor will matter much, because they will have pins. That's simple, that's easy. So I guess 1500, not 1500, 15. It gives us a lot of space. I don't hate it for now. We might need to change it if we diameter 4.5, 15mm length, 10mm, pitch 15. I would look at the ones you want to buy first. That is fair. But for now I'm gonna add them because I can then go and do the thing. I really like doing the thing. Let's see. Oh yeah, it's been such a long time since it worked with no errors. Okay, yeah, so these are already way too big, but that's only temporary. Perfection. Okay, we haven't loaded it. That's already a big step for me. Just as a curiosity, once again, it was when you increment 100 nanofarads for decoupling. Okay, so what is a decoupling capacitor? Which one? I remember you explaining this to me once, but I already forgot. Because I need to figure out how many farads the ones I need to buy would be. I can just buy a kit. I'm probably gonna buy a kit. I'm buying a kit. make it as robot. He does not think it is enough proof of saying he's a government idea. Me, a robot? Come on. Don't be ridiculous. Preposterous. The source of the power fluctuation. So the main power needs capacitors to keep the current stable again. Yes, so this is a decoupling capacitor then, which means you recommended 100 nanofarads, right? I need to buy a kit anyway because I cannot buy capacitors whenever I need them. This is gonna slow down the whole process so much for no reason. Okay, and we need the ceramic ones. I forgot the Polish one for such. I'm glad I bought a kit of capacitors and they are all the wrong kind. Isn't that fun? I still don't know. One is micro and the other is nano. I did notice that, don't worry, but I appreciate you letting me know just in case. I need a surround. Okay. Kit of 300. Let me see. What kind of do you have? 2.2 nanofarads, 100 nanofarads. They don't have any micro though. I'm just gonna add it to the now. Oh wait, 100 nano for the coupling ones, right? Would that mean that right here in this case I do need the 100 nano ones? That's linked to Amazon. I don't use Amazon because it's really expensive for me. Oh, that's the book, right? 5,000 pieces. The book. Ah, it's pricey. Okay, you know what? I might order the book as well then. Alright, fine. I'll finally order the book. I don't know how long it's been since I was supposed to buy the book, but about time that I finally buy the book. Okay, but just to make sure, in this case the 100 nano would work then, right? Because that's... Okay. Hi, the Tefta. Oh, we haven't chatted in such a long time. So in this case, the 100 nanofarads would work, right? Because that's what I'm using it for stabilizing the...
Well, why do you have so many of them?
Well, it's because in the data sheet, this is what it looks like. And like every single time there's a new LED, they add in the capacitor.
That's interesting. I forgot that they did that. Yeah, because when I usually design stuff like that, I just use the surface mounted ones. I don't. It depends on the ceramic capacitors that you get, but yeah, I think that should work.
Okay, and the 100 nanofarads, right?
Well, is that what the data sheet says?
The datasheet
The
says
data sheet.
C104, but there's absolutely no units.
Really?
It is a rather thin datasheet, and it's, well, let's just say written in not exactly English.
Okay, just a second.
Like, follow the order of GRB to send data and the high bit sent at first. Oh no, wait, that actually is English. I take it back. That could be understood.
And they're connected to the data line, right?
Yeah. They keep following through the data line through it.
Yeah, so AI is saying like 1,000 microfarad is fine, or 100 nanofarads is pretty good.
1,000 microfarad? That's a millifarad.
Yeah. Or 0.1 microfarad. It depends on the voltage rating, and since we're at 3.3, you don't want anything greater than 1 microfarad, it says.
Okay, so
They
just
don't
low.
handle. You're trying to avoid inrushes of current. So yeah, maybe like 100 nanofarad is pretty good.
Okay, then those I just ordered. That's good then. So let's switch the thing.
But yeah, with those books, make sure that you have the footprint size. Like I had all my pads as 800s, and I ordered a book that had 600. So all my pads were the wrong size.
I don't know when I'm gonna get to that level because, to me, surface mounted stuff is a commitment I'm not ready to make.
Yeah. It almost becomes a necessity when you're designing
Oh, I
PCBs that are
imagine.
small.
Like, I imagine eventually, like, your PCB, if you wanted to make THT, then I imagine it would be just like half a meter long.
Probably. Yeah. But you know what I bought for through hole or THT capacitors? They're those small ceramic disc capacitors. They look like yellowish or
Yeah,
orange.
those are the ones I ordered right now, yeah.
Awesome, awesome. Sorry I couldn't watch the stream and
Oh,
chat.
no, I didn't do it on stream because, bank data and such. But
Oh, yeah.
one thing, hold on. Oh, yeah, I was about to say that kind of funny of me to say that I'm not ready to do surface mounted stuff and, not too big of a commitment and such, considering the choice of LEDs I just made. Because
Our surface mounted,
they
yeah.
are surface mounted. I need to order some of them, by the way, because I did order them with I did order like 10 of them, but with their own dedicated little board. And I feel like it's pointless to design a PCB if I'm gonna design a board, so I just need to order them as well.
Yeah, and those ceramic surface mounted capacitors are really cheap on AliExpress. Because if you get like the biggest ones are the 1200, and since those LEDs are already surface mounted, you might want to just buy some solder paste and a syringe, and
Yeah.
because you can solder those usually depending on where the pads are at just with a soldering iron.
Soldering syringe might be useful.
Yeah, because that solder paste in yeah, I know it's pricey. But the flux, right? Because when you put if you have flux in a syringe and you put the solder paste around the pads and you put a whole bunch of flux around it, if your soldering iron is touching the liquid flux, the flux is like a heat transfer for you. So it helps make sure that the heat gets dissipated. So you can use your soldering iron as if it's a heat gun by putting it by the component and just melting everything.
I mean, okay.
So it's not like you touch the pad. So if you have a syringe of solder flux, you have another syringe of solder paste, you know, and any soldering iron you can do surface mounted.
I mean, yeah,
and I
because
would just recommend
because PCB,
the biggest component.
yeah, because I mean PCB, and then take a syringe, apply all the solder, and then not even a soldering iron, only a heat gun, and I don't have to worry
Yeah.
about breaking anything because it's just an empty PCB, and then everything is gonna melt right into place. I don't even know if I'll need flags in that case. I mean, I still have it, but I don't know if I'll need flags. If there's nothing on it, I'm blasting it with 600C. Oh my god! Fine,
Yeah.
I'm opening up again. Was it this
If you're
time?
ever doing surface mounted like those LEDs are, you'll want flux and solder paste. It's like you need it to clean up the board, and a ton of solder wick, you know, the copper wick.
Theft are a bad influence on me.
Mm-hmm.
Okay, hold on. Let me just. I'm gonna buy it all. No.
My goodness.
Oh, okay. This is a very expensive mask for no reason. There we go. And now what do I need? I need to draw the thing, right? Rule areas? Oh, which one was it? Was it the rule area? Or the filled in zone? Just draw a rectangle. No. Oh, was it? Wait, was it just draw a rectangle? That's it? Is that how you make a PCB? Like this. Oh, that was Irish accent in me. I didn't even notice. What is the size of it we'll need? Well, I imagine the maximum would be this point. Okay, fine. We won't measure it in this case. We'll just go down right here and measure it. Okay, fine. What is your size? Or can I really not select the point? Do I really need to make a line? Like this. Just to measure it. 6530. Not. Wait, no. I'm measuring the wrong thing as well. Oh, I am really flabbergasted by this entire thing. Everything is blue indeed. Okay. $103. Okay, 10 centimeters. That's a fair bit, I'd say. Not a little. So we have the design to make, which means 100. A 100 by a centimeter? We can actually probably go. Yeah, well, let's keep it at a centimeter for now. Oh no, we need more because of the amount of LEDs we've chosen. Unless we just delete a bunch of them. That's what's nice about it. We can just go and reduce it to 8. Are you building lasers in Mask? Not quite, but I am building, well, lights. Updates. Well, you didn't really seem to update you. I said update. That's not updating, that's keeping everything exactly the same. Well, unless I need to delete everything and then update. Here we go. Oh, okay. Festive. Oh, this is the capacitors. These are the LEDs, right? First one. Why is it connected 2 to 4? Oh, that's D out. Wait, why is it D out connected to D out? It can't be a laser now. I could add in lasers if I wanted to. Oh, both of these are D out. Well, that's fun. D2 to D out. Oh, D1 D out, so it should be like this. There we go. I do have to say, the lack of alignment of any sort is absolutely killing me. I can't snap to a line. I beg you. My laziness is winning over my OCD. There we go. Go on. Oh, the price for the capacitor as well, right. Of course. It's not from like half a millimeter. This. Oh, that is lovely. If only they snapped to the same line! I'm fine, I'm okay. Delete absolutely everything. All of it, delete. Update, again. Now the snap is half a millimeter, and they're all equal lines. So we do it like this. Now, should we put the capacitors right next to them? I imagine, yeah. So I feel like we should do it like this. I feel like this would work well. Okay. Beautiful. Is this an engineering channel? In a way. I like to keep my fingers in a lot of pies, you know? A little bit of everything all of the time. There we go. I guess I could bring them all in a bit closer. I don't care for it though. I wonder if the automatic connections will be able to handle it. You'll do a tutorial on how to brush your teeth, you ask. New video idea! I just realized that I don't know if these are backwards, but to be fair, it'll be easy to flip them, so. Okay, this is the basic idea so far. Now, all of these are between ground and... No, we'd like an additional ground. I imagine we prefer the ground to be just different, wouldn't we? Because we don't want the ground to go across like this. We'd rather have the ground go all the way to the end, then flip, and then back connect them in. Yeah. Brushing your teeth tutorial. Genius. Okay, we're gonna do manual routing because I don't trust the automatic routing. It has... Last time it gave me a bunch of invisible lines. Wait, beforehand, can I save this kind of backup or something? Oh, whatever. Then ground will go forward, over, then under. No, we need it this way, wouldn't we? I really would like to do it on a single layer because I can geometrically. But the temperature will be made. I don't know yet. It requires a massive budget. Yeah, I mean, I imagine that no underneath ground on the second layer. Let's be reasonable. top layer will have the voltage like this. Right. And then over here we'd actually like a double pin for the voltage. And also the pin for the data. Right. Like this? I think so. Can I just connect it? How do I add it, like, going through? Do I need a... Oh, I feel so smart for figuring this out. Hold on. Need a... Yeah. Oh, I feel so clever for thinking of this. Even it's okay, it's a bit trivial, but I still feel very clever for coming up with this. There we go. There we go. There we go. Oh no, cancel. No, piss off. Cancel, piss off. Oh, I feel so clever for figuring this out. Even though it's like PCB making 101. Oh, you are just a real piece of work, you know? And the voltages need to be connected, which won't be a problem because we can just connect them like this. I don't know why some of them are going in a straight line, some of them not. I imagine it's because I messed up the placement of a slightly. I'm not fixing it now. There we go! Wait, is this functional? Pardon my absolute lack of faith. There's one more thing we need, and that's pretty simple. A symbol of... Oh, what were the pins? Oh, it was con 01x03. I think. This is actually going to butterfly that. Okay, so we do this, and then this will be our connection. So we'll have data, ground, and voltage. We need the thing, don't we? What would be your thing? What's the pin thing? I remember it was silly. Wait, no, connector. Banana jack? What am I doing? Just header, right? 3 1mm. I think this, correct? Pin header 3 vertical? Because that's effectively what we'll have over there. Connector. What in the unholy make it? Connector. Header pins are 2.54mm pitch. What pitch am I looking for? I don't know anything. Solder wire. Oh, I see. Connector group. What kind of wacky... I'm sorry, what kind of wacky, absolutely wacky footprints are these? Okay, no. We need the connector group. So it's this one. None of these look normal. I don't trust any of them. I mean, banana jack seems fine. Did you see connector header pins? Oh, because there's a bunch of connectors. I didn't see that. Connector Pin header, there we go. Right, that makes sense. Okay. $2.54, okay. Vertical, that's actually a good question. Vertical will allow me to go like this. Horizontal will allow me to go like this, however. Horizontal's not bad. No, I feel like vertical. Yeah. So this. What do we call this software? KiCad. That's the name. Okay. I imagine like this. The reason why being that it's right next to the... I'm an idiot, not like this. It's like this. Because then we can add the data to data, voltage to voltage, and ground to ground. Tefta, is this correct? I don't trust it. I made it. Obviously I don't trust it. Wait, first of all I need the rectangle, right? Wait, do you just do it copper like so? I don't remember which one allows you to set up the overshadowed by capacitors. I mean, from one side a bit. Unless I pop the capacitors on the back and LEDs at the front. Right? Edge count boundary. How do you make the edge count? Oh, edge like this. I don't like the fact that nothing is snapping. It's not nice. I like it. Now, these will be just backwards. The other side. And then it should be a problem, right? So, would you say that those are LEDs? Yes, that's what I meant by light. Okay. There are a couple of things. One thing which I'm kind of worried about is that these might not be able to handle the thing. Where's the voltage? I'm kind of worried that these won't be able to handle the currents. Yeah, this might need to be thicker. How do you change the thickness? I remember it was... I should first figure out how to change the thickness and then only select them all. Okay, this. How do you change the thickness? Right click? Laser that bends to metal. I can't build that. I don't know how. Oh, what was the button for? Actually, what was the thing where you change the size? Because the data, that can be thin, that's fine, this is data. But the ground and voltage, yeah. Tools? No, I'm guessing. I'm just guessing! What was the double click? Wow, never mind. Can I select two of them and double click? I can, perfect. Let's do 0.6. Even more. Can I do a 1? Kind of in a way, it seems like it. Really should have done that before I drew it all, so that would be much easier. Just the one. That should be a bit better. I feel like I'm making a mistake, but yeah, I really wish I had something to say. Doesn't matter. Okay, ground on the top right now. Select all the connections. Once again, we'll do 1 millimeter. I could do the Tefta trick where I like set the whole area as ground, but that's my first reasonable PCB. I am not fucking about with it. I don't feel like fucking around and finding out in this case. Short net of yeah, probably shouldn't, should I? I know why, but that's so funny. Let me guess. Are you fine now? Yeah, okay. Oh, it's absolutely hilarious. Need help falling asleep at work. Oh, I don't know if this live stream will help you, Acronymus. Sorry about that. I'm designing a PCB. It's about as boring as it gets to watch. Man, I'm a good streamer. Okay, splendid. Let's see how it looks. I can yell into the microphone at a random time if you want. I won't tell you when, and that will like shake you up. Like no warning. I'm just gonna all of a sudden, I'm gonna slowly turn down and then get more and more quiet. Plug in my phone into the charger and just generally remain very quiet until eventually. Would that be fine for you? Would that work to wake you up? Oh, I need to know. I need to know all of them. The PCBs and the LEDs. How long is the delivery gonna be and how much will they cost? So many problems, they're gonna be so annoying. Okay, let's go for it. We did a lot of work today, I have to say. It may not seem like it, but some pretty big changes to the mask. Yeah, I think it might be it for the day. We've done, you know what? No. One more thing before I go. Hold on. Let me just really quickly switch to the camera. Big book camera. You pee all over the CB. Oh, all over it. Hold on. I need to go and get myself some. Okay, I'll be right with you. I'll be right with you. Okay? Right with you again, just there we go. Fresh out of the oven. So this I'm gonna leave for now. That'll be for later. That'll be for later for the mask. This, however, as I mentioned, the mold is absolutely tiny. This is the mold I've made before, and it is absolutely tiny. And the basic idea would be that we would take the industrial piercing, we'd place it in there, we'd enclose it with all of these. Oh, this is a pain to assemble. Get in. Oh, this is such a pain. I should have thought of some kind of more clever way to assemble it, actually, because this is a pain. For no reason. Because we didn't much, because we didn't distract you. Don't call them distractions. Whenever you do, I have a lovely time. I love conversing with you all, you know? Yeah, instead of these squares being solid, I did it like a liquid, like a solid snake, then this would be so much easier to right now fit in and just snap into place. Yeah, that's what I might need to do. Also, I might need to increase the size of the middle. Yeah, so I basically need to reprint it. Cool. Neat. Festive. Anyway, I think that's it for today. We did a lot of work, we designed the PCB, we updated the mask. It was proper. I am really behind on this video though. That's the only problem. Like, the progress for the video was going pretty well, but the video itself, not really. So I need to go and make that happen now. Okay then. And for now, I suppose that'll be it. Thank you everyone so much for watching and have a great day. Bye.